Okay, let's think about where the electrons are in an atom now. Obviously, we've said before that they are around the nucleus, but we need to be a little bit more specific about where they are. And what actually happens is the electrons go into shells or energy levels around the nucleus. So think of like a Russian doll that that basically electrons can go at certain distances from the nucleus, and each shell has electrons in it. A bit like an egg with an egg outside it and then an egg outside that. Now, each of these shells has a maximum number of electrons. So, as you can imagine, the shell that's closest to the nucleus is going to hold fewer electrons because obviously it's got less volume, less space. So the first shell can only hold 2 electrons, whereas the second shell can hold 8 electrons. Now, without going into too much detail, remember that electrons are also negatively charged, so they repel each other because they have the same charge. Like charges repel, so they need a bit more space if they're going to be together. So in shell 2, we can have 8 electrons. Shell 3, which is further from the nucleus, we have a possible 18 electrons. Shell 4, 32 electrons, and so on. And that's well beyond IGCSE. Now, this is an important point. The number that the shell has is the same as the period in the periodic table, which is the number down the left-hand side. So if you need to know how many shells a particular atom or element has, then all you've got to do is look at the period it's in. So for example, hydrogen is in period 1, so hydrogen has 1 shell of electrons, whereas lithium, beryllium, boron, they're in period 2, they have 2 shells of electrons. Sodium, magnesium, etc., 3 shells. Potassium, calcium, 4 shells, and so on. These are the period numbers. So if I said to you, how many shells of electrons has barium got, you would say what periods it's in. Period 6, so it's got 6 shells of electrons. At IGCSE, we need to know the electronic configuration of the first 20 elements. So we have to say where the electrons are in the first 20 elements. So let's work through these now. This is not that difficult. Hydrogen's got 1 electron, so its electronic configuration is 1. Helium, 2 electrons. Both of those electrons are in the first shell, so electronic configuration 2. Lithium is in the second period. It's got 2 shells. So what it has is 2 electrons in the first shell and then 1 electron in the second shell. So the electronic configuration is 2, 1. Beryllium would be next. It would have an electronic configuration of 2, 2. Boron 2, 3. All the way along that period until we get to neon, which has got an electronic configuration of 2, 8. 2 electrons in the first shell and 8 electrons in the second shell. Then we jump to the next shell. Sodium has got 2 electrons in the first shell, 8 electrons in the second shell, which is now full, and then 1 electron in the third shell. So its electronic configuration is 2, 8, 1. Magnesium's next to it, and it would be 2, 8, 2, 2, 8, 3, etc. Until the end of that period, you've got argon, which has got 2 electrons in the first shell, 8 in the second, and then 8 in the third. Now, this is where sometimes students can get a little bit confused, but just keep these ideas simple. When we get to the next period, period 4, the first one we talk about in period 4 is potassium. Potassium has 2 electrons, 8, 8, and then 1 in its outer shell. Now, the observant among you will have realized that I said that the third shell had a capacity, it could hold 18 electrons. But that's not something for you to worry about at the moment. You just need to understand and to know that potassium, instead of that last electron going into the third shell, it goes into the fourth shell. And we'll forget that the third shell has got 18 capacity for the time being. So potassium's electronic configuration is 2, 8, 8, 1. And calcium's is 2, 8, 8, 2. And that's what you're expected to know for IGCSE. Now, a couple of notes. Noble gases have got a full outer shell. And a full outer shell is a very stable, very unreactive situation. So essentially, the noble gases don't need to do anything to become more stable. They're already very stable. Now, the noble gases, it says name the noble gases. There are the symbols helium, neon, argon, krypton, and xenon. And you can see that they have 2 electrons, 8, 8, 8, and 8. We consider these elements, these atoms, to have a full outer shell and be very stable. A second note, the electrons in the outer shell of an atom are called the valency electrons. The outer shell electrons are called the valency electrons. Now, we'll come back to this idea, but the noble gas electronic configuration is something that all elements try to attain, they try to get, because of its stable nature. Right, it's very easy to see how many valency electrons an atom has by looking at the group number. So these are the group numbers. Forget about the transition elements for the time being. The group numbers are 1, 2, so hydrogen heads this group number, but technically the metals are in group 1, lithium, sodium, potassium. 2, beryllium, magnesium, calcium. We jump to boron, aluminium, gallium, etc. Group 3, group 4, headed by carbon. Group 5, headed by nitrogen. 6, oxygen. 7, fluorine, chlorine, bromine. And then group 8, sometimes called group 0, are the noble gases. So, if I say to you, how many electrons has carbon got in its outer shell? How many valency electrons has carbon got? You can say, what group's it in? It's in group 4, so it's got 4 electrons in its outer shell. Oxygen, it's in group 6. How many electrons in the outer shell? It's got 6 electrons in its outer shell. It's got 6 valency electrons. These are all little bits of data that's going to be very useful later on. So group number gives me how many valency electrons an atom of an element has. The period gave me how many shells of electrons that particular atom had. Okay, let's have a look at the following table. Now you should be able to fill this table out for the first 20 elements. So essentially you have to be able to say how many protons, electrons, and neutrons the element has, plus to give its electronic configuration. So for example, hydrogen. Hydrogen's got the symbol of H. How many protons? We know this probably off by heart. 1 proton, 1 electron, and 0 neutrons if we're talking about hydrogen 1, so that particular isotope of hydrogen. There are other isotopes of hydrogen, but we'll talk about them later. So its electronic configuration, as we just saw, is very simple. It's just 1. If I take something like lithium, now this is where we're going to look at the symbol from your periodic table. If I look at lithium, lithium has got a proton number of 3, so it's got 3 protons, It must have 3 electrons if it's an atom, because atoms have the same number of electrons as protons. And then 7 subtract 3 gives me 4 neutrons in this particular version of lithium. Lithium's got 3 electrons. It's in period 2, so it's got 2 electrons in the first shell and 1 in the outer shell. Okay, so you should be able to go through all of the elements up to calcium and complete this information. I'm not going to do all of them, but just to give you an idea of how to do it. Let's have a look at potassium. Potassium has got 19 protons. There they go, look. It's got 19 electrons if it's an atom. And then 39 minus 19, it's got 20 neutrons. Electronic configuration. It's got 2 electrons, so it's in period 4. It's got 2 electrons in the first shell, 8 in the second shell, 8 in the third shell. That's 2, 8, 8. That's 18 so far. 1 more left over, 1 in the outer shell. So its electronic configuration is 2, 8, 8, 1. Right, a lot of information. Have a look back over it, read the pages indicated, and answer the questions. There's also a video for you to watch on basic atomic structure, just to revise what we've done so far.